Hello, Houston. We're going to start with a small question here today. What is the most basic science? Not having warned the class, we're starting with that. What is the most basic science? Get on the mic and give me an answer. What is the most basic science?
Psychology.
That gets you an A, but it's a wrong answer. It's
Physics.
Down in the middle. What would be more basic than psychology?
Sociology.
Wrong direction.
Physics.
Physics, I would argue, is the most basic science of all. What comes next? What is slightly more complex, not complex, but sophisticated than that? Less basic, maybe is the best way to put it. Chemistry, I would argue, is next. What then comes? Biology, and then, you ready?
Psychology?
Right on target. Very good. Okay. And then sociology, and so forth. What's the basis on which that continuum, which is in the simple Psych book, which is where the answers are obviously coming from, on what basis is that continuum being organized? Why do I put them in that order? Physics, chemistry? Because, see, you might argue philosophy or math is most basic, and I would agree with that. But those really undergird all of the others. So when we get to content areas, I'm going to argue that physics is the most basic. On what basis am I arranging that continuum? Well, that's true of generally of sciences, but no, I'm looking for a very different kind of basis for why I put them in that particular order. What might it be? We could do 50 minutes of staring at each other today if you want.
Is it because you use it every day? Like, you use it?
They're all used, but I see both of those I'm going to suggest are reasons why they're defined as the disciplines they are. Now I'm going in a very different direction, and you've headed in the wrong way, and that means you'll probably not come back for a long time, so let's don't waste tape. What I'm thinking of is the size of the unit of analysis. Okay, what is it that's being analyzed? What are physicists studying, or at what level do they actually analyze the world? The answer there would be that it's at the very most basic level. That is, they're studying the fundamental laws of magnetism, of electricity, of gravity, and so forth. Okay? What is the basic unit of analysis for chemists? You might argue the atom, but I'm going to put it at a slightly larger level. I'm going to say that that's where the physicists really are, although truly chemists are now down to subparts of what I'm actually thinking about here. What's the periodic table constituted of? Elements, yes. So the elements are the basic units of analysis for chemists. What about biologists? Get on the mic.
Cell.
You have to press a button to be on the cell.
Cell.
Cell, yes, to be on the mic is what I should have said. The cell. What then is the basic unit of analysis for psychology?
The organism?
Yes, the intact, functioning individual organism, the human, okay, or the animal. And for sociology? Get this one, you all get A's. What'd you say?
Groups of organisms.
Yes, groups of organisms. See, I don't like the cheating here. They give the answer, and then if it's right, then they'll go on the microphone. Shame. Okay, so if you see where I'm headed, we start from the very most basic concepts and move toward cells, individuals, groups, and so forth. So what I'm arguing is that the reason we put the disciplines in the order that they're listed in the simple psych book is because of the increasing size of the unit that is at the base of that discipline. What that does is to put psychology right in the middle with a very interesting choice. And that is, as a psychologist, we can look two different directions for potential explanations for what we're studying, okay, as is true of many of the other disciplines. Basically, if we look downward, if we look to the more basic science, biology, we are engaging in what is referred to as reductionism. And in essence, with reductionism, what you're looking at, any scientist who functions as a reductionist is basically trying to explain the principles of his or her own science in terms of the next more basic discipline, okay? So a reductionist, as a psychologist, would look toward biology for the ultimate explanation. As an example then, if we look at subdivisions of psychology, we find that neuroscience is one of the areas that is very prominent in our discipline now. That reflects a group of people who are in fact going toward the utilization of trying to explain the phenomenon at the next more basic level. Okay, so a reductionist is a psychologist who functions as a reductionist is looking at least to physiology to explain whatever principles it is that we're studying. The second approach, however, the second possibility is that instead what we do is to engage in emergentism. Emergentism is basically going to argue that in fact we look the other direction. That is, the most basic explanation for psychological principles then, an emergentist would argue, is found at the level of sociology. You will remember the other day when I was talking about, in the other lecture, when I was talking about the Gestaltists. Gestalt psychologists are basically emergentists. That is, if you remember, we put 4 lines on the screen, and depending on how they're organized, determines how you end up reacting to them, okay? Something emerges out of the combination of those lines to give us something that we might not necessarily have been able to predict, even if we knew everything there was to know about a single line. That is an emergent phenomenon. A number of years ago, the Department of Psychology ran several colloquia back when our institutions were rich enough to have money to do this kind of thing. Instead of bringing in 1 speaker every Wednesday, as many departments will do, we brought in 6 at once for a 2-day colloquium. Each of them gave a paper, but some of the best stuff that came out of those conferences was where those 6 psychologists were focused on an issue, talking to and with and against each other. So that in essence there was a synergistic effect that came out of putting all those people together and turning them loose on a particular topic. So in essence, that's something that emerged out of the combination of the individual units to give you a richer kind of understanding. So in essence, a reductionist reaches downward to the next more basic discipline. An emergentist, in some sense, reaches upward for a more complex, a more interactive kind of response. Most psychologists, I would argue, are reductionists rather than emergentists. Okay? Most psychologists function as reductionists. So at this point, we've defined psychology and we've put it within the context of the disciplines. Now what I want to do is to talk a little bit about what psychology is not. One thing I want to separate psychology from is common sense. Okay? I want to argue that although we use common sense, it is not a discipline of common sense. Follow with me, camera. We're going to wander here a little bit. Your grandmother may already have been on your case about the fact that you're wasting all this money studying human behavior. Okay? She is saying something like, sit at my knee, I will tell you everything there is to know about men, about women, about life. Okay? But what she's doing is the following kind of thing. We might hear a woman say something like this.
I haven't got a letter from my guy in 2 weeks.
Well, you know what they say, what Granny will say in that case is, out of sight, out of mind. But a little bit later, we hear her say,
but I saw him this morning and he missed me so much that he cried.
And Granny then says, absence makes the heart grow fonder. Okay, so Granny's covered either way. We might hear a gentleman say something like this.
I got an offer of $500 yesterday for my old car. If it's worth that much, I'm not sure I want to sell it.
And in that case, Granny is going to say, look before you leap. And then a little bit later, we hear him say,
I tried to accept the $500 for my car, but the guy said I waited too long. He bought another car.
And in that case, Granny's covered again. She just says to you, he who hesitates is lost. Okay? So she's got it either way. And the problem there is that that kind of an argument is very commonsensical. I mean, Granny can tell you, all sorts of reasons why that actually is the best way to react, regardless of which piece of advice she's actually given you. But what she's doing is taking what's called a common sense approach in this situation. That's not the way psychology operates, because in essence what we were doing there is arguing in a way that philosophers call ad hoc. That is, it was to this. It was only to the immediate set of information and behavior that we're trying to explain. What psychologists are looking for is the underlying common elements that will always operate, so that there may be nuances in a particular variable which cause us to predict one thing in one situation and another thing in a different situation. But we are normally looking for a specific underlying explanation rather than an explanation that changes every time the data changes, every time the behavior changes. So I want to separate us from pure common sense. We try to apply it, but it's a more basic level of analysis that we're engaged in. Another thing that I also want to separate us from, in addition to common sense, is what I'm going to call the parasciences. And I want to put up here for you a couple of examples of the parasciences. One is what's called phrenology. Phrenology is basically a bumpology that assumed that the mind is located in the brain, and it literally involved measuring under and overdeveloped portions of the skull. So that there were people wandering around London 125 years ago, measuring the lumps on people's heads, literally trying to decide where the area for love was located. They've got another one for language, another one for math, another one for science. And they had basically quantified the head into sub-areas, basically. And they were measuring the size of each part of a person's head and using that to predict whether they were good as a scientist, as a lover, as whatever. The problem with that is that it's predicated on a whole series of assumptions, all of which turn out to be wrong. One is that the skull is uniformly thick. It isn't. Another is the skull size is directly reflective of the complexity or activity that goes on underneath it in the brain. It isn't. And the third is that brain size directly responds to activity. It doesn't. And the complexity of activity, the one thing we do know now is that there is likely to be a greater amount of innervation, that is interneuron connection, in a given area of the brain that has been particularly active, and there are likely to be more support cells, what are called glial cells that we'll talk about much later, in there. So there is a greater degree of food being fed into that area of the brain. But the idea that that brain somehow then impacts the shape and size of the skull is simply wrong. It's not right. So essentially, phrenologists were off base. They operated like scientists. They had very precise measurement techniques. It just didn't relate to anything that could be directly documented. The second discipline that I also want to talk to you about is what's called astrology. Astrology basically conveys mysterious facts and ancient truths, the bases for which are seldom, if ever, discussed or studied. But in essence, what it boils down to is looking at the pattern of stars and using that to predict whether today is a good day to proposition the boss for a raise. Just in consideration at that level, the ludicrousness of that kind of an approach begins to spring forth here. I used to have an activity I did a number of years ago where I would come into class one day with several people's birth dates having been identified off the student records, so that I could have a prediction for Sagittarius and Taurus and Aquarius and so forth. And I would indicate that, I've looked at this stuff and it really looks hot. I'd like you to take this as a prediction generated out of the stars for this weekend, and I'd just taken it right out of the paper. And see how well it works. And they would come in bug-eyed on Monday mornings and say, wow, this stuff really works. It's amazing. And I would then have to destroy a lot of trust by saying, I meant to tell you, I mixed up the labels with the predictions. And in fact, what I had done was to simply take the actual predictions out of the newspaper and rearrange them. I put the label on one for the prediction of another and totally randomized them. And yet people would have what essentially was a self-fulfilling prophecy. This is what was said should happen, and by gosh, when we look at it, that's what did happen. But that's the problem with astrology. Nobody ever goes back to set up the independent variable experiment to see whether manipulating this actually impacts that. But if you think about it in detail, the very idea that which side of the tick of midnight you're born determines whether you're Aquarius or what's before it or what's after it, and that the predictions then change because of that, begins to show you some of the difficulties that astrology has. It simply operates as a parascience. It's very precise in what it measures. What's missing is any consistent demonstration that what they've measured and predicted relates to the behavior that it's trying to impact, other than a self-fulfilling prophecy. As a psychologist, my best advice to you would be that the best way to get a raise from the boss is to ask him or her. I think there's no other variable that would more often predict a raise for you than the fact that you've gone in and asked with a documented set of records as to why you ought to have the raise. That'll work a lot better than reading the paper and decide, oh, today's the day, or today's not the day. Now, when we get to what psychology is, there are a couple of things that I think are crucially important to understanding what we're talking about. One of these is what I'm going to call an operational definition. This is one of the concepts that's really central to the operation of psychology. And in essence, what operational definitions require is that we essentially define or describe an event or concept exclusively in terms of the procedures that we have used to measure it. Let me read to you from the writings of a physicist named Bridgman in 1927 who first introduced the concept of operational definitions. What Bridgman said was, consider the concept of length. What do we mean by the length of an object? To find the length of an object, we have to perform certain physical operations. The concept of length is therefore fixed when the operations by which length is measured are fixed. That is, the concept of length involves as much as and nothing more than a set of operations. The concept is synonymous with the corresponding set of operations. How far is it from here to Dallas? 244 miles from where I'm sitting. What's a mile? Well, a mile is 5,280 feet. Well, what's a foot? Well, it's this long. And it's 12 inches. What's an inch? And at some point, you have to step away from that and give an operational definition. And there is a standard measure at the National Institute the National Bureau of Standards and Measurement in Washington, where there are specific reference points for what we mean by a foot, a yard, and so forth. That's the operational definition. First study I ever participated in as a graduate student where I got published was one I conducted when I was in graduate school during a summer activity. I was employed at Massachusetts General Hospital. The person for whom I was working was doing a study of alcoholics. And what he was trying to demonstrate was that alcoholics are socially isolated or socially isolate themselves. My task that summer was to go into the emergency ward admission log at Mass General and pull out a single sheet. Each person who came through the the emergency ward had a single sheet of information collected about them, front and back. Height, weight, race, sex, where you were employed, whether you were employed, whether you had insurance, what kind of insurance, the job you had, and so forth. And then I took 200, so it was like 10 a month for 20 months that we did, where the operational definition of alcoholic in that study was, if the word alcohol or anything related to drinking appeared anywhere on the front or the back of that sheet, that person, for the purposes of our study, was an alcoholic. And then our control group was simply the next person who came into the emergency ward for whom nothing related to alcohol or drinking was on their sheet. So we drew two samples over essentially the same timeline. Half of them had alcohol or something related to drinking on it, half of them did not. And then we simply compared the two groups. And the conclusions were amazing. In 17 out of 18 variables, it went in the predicted direction. Alcoholics, as a group, compared to non-alcoholics, were less likely to be employed. If they were employed, the job was likely to be a lower socioeconomic job. If they were employed, they were less likely to have insurance. If they did have insurance, they typically had less. If they came when they were brought into the hospital, alcoholics were more likely to be brought in by public means than by family members having been brought in. And the most poignant of all was who they listed as next of kin. The non-alcoholic group will typically, when asked to list next of kin, will list either a parent or a child. That is somebody right on the family line. An alcoholic, by contrast, typically lists either a brother or sister or an aunt or uncle, suggesting that they have driven themselves away from or isolated themselves from the main family line, parents and children. Now, if you read that study and you're at Seattle General and you think to yourself, bull, You can take that study and go right into your own emergency ward at Seattle General, if there is such a hospital, and create another group exactly like the one that we did, and do your own comparisons. You can create your own set of data and see whether we were in fact correct. In other words, you can replicate. That is an advantage of an operational definition. It externalizes it and defines concepts directly in terms of what we're actually dealing with here. Okay? Let me give you one specific example of an operational definition. And that is in your book, in the Simple Psych book, there are 3 graphs there that show you what each of 3 different survey results give for you in a survey conducted by the American Psychological Association. We're going to put just this one on the screen here for you for a minute. And in essence, what this one asks you or responds to, summarizes, is the degree of responses that we get from psychologists when asked members of the American Psychological Association, what do you call yourself? What are you? And you will see here that in the most recently available data, the most common answer is, I'm a clinical or community psychologist. So the largest single type of psychologist, the largest group of people who are in psychology will call themselves clinical community psychologists. 25 years ago, that was only about 1/3 of all people. So this is clearly a growth area. If you look at this graph over time, you will find that 25 years ago, only about 1/3 of all people were clinical psychologists. So this has been moving in the direction of greater numbers of people in clinical community psychology. Interestingly enough, across the graph as a whole, there are more people in each of these categories than there were 25 years ago, but the proportional number in related areas such as experimental psychology, physiological psychology, and so forth has gotten relatively smaller. Second question that they're asked is, where do you work? It was the case back in the mid-1970s that educational institutions employed about 2/3 of all psychologists. You'll see it's down now to about 1/3. So there's been a significant migration toward being involved in practice or treatment in one way or another. But this is the current status of what the discipline looks like. And a third area, we're going to flip pages here and kind of goof up your screen for just a second and look at one more, is what kind of work do you actually do? This is here, we'll give you this one. This is a third way to look at it, and that is, what kind of work do you actually do? No one psychologist does these things, but it's a pretty good cross-section of what the discipline as a whole does. So in essence, as you can see, a large number of people are faculty. This used to be the largest block. Now the largest block is those that are offering direct human services. They are offering psychotherapy, they're conducting tests, they're involved in counseling or various activities like that. So that is one way to operationally define the discipline of psychology. We can operationalize it simply in terms of what people actually call themselves. Now, I'm going to show you another way to operationalize things in a slightly different manner. We have a rat with us today. This is a male albino rat who was born 120 days ago, and he is generally referred to as Chantry. So we're going to put Chantry on a chair here, our lab rat, and we have a researcher who is going to ask this rat a series of questions in a way that rats can actually answer those questions, okay? So this rat is looking around. We want to know what it is that's driving this rat at this particular moment. What kind of things might a rat like this be looking for if we put him up on a lab stool, as we just have with this rat? Out of the class, what might he be looking for?
Female rat.
A female rat. Get on the microphone so they hear you.
Female rat.
In other words, sex. So that's one possibility. What's another? What else might he be looking for?
Food.
Food would be another possibility. So he might be hungry. What's another possibility? I can think of at least one other obvious one. If he's not hungry, he might be
Thirsty?
thirsty, yes. So we've got at least 3 possibilities of what this rat is looking for rather nervously right now. He might be hungry and looking for food. He might be thirsty and looking for water. Or he might be sex-starved and looking for the rat version of Miss America, which is another possibility. So let's in fact test this. We can actually do that. You can actually ask a rat any question, or any animal for that matter, anything that is within its own behavioral capabilities. You can ask an animal any question that a human would answer yes or no, and the rat's behavior will tell you. So our researcher is going to ask, first of all, are you thirsty? And we'll see what the rat's response actually is. When offered, the answer clearly is no in that case. Now the second possibility is sex. Okay, the answer is clearly no again. The third possibility then is hunger or food, that food is what he's seeking. Let's see what happens in this case. And the answer in that case was yes. Okay, thank you, rat. Thank you, researcher. So in essence, what we've done there is to pose three different questions to that organism. And what we've decided is, in this particular case, that he is hungry. Okay, he is hungry. Let's look at that in terms of the next diagram down in your simple psych book and define several important concepts out of that. The concept I'm dealing with there is this one. Okay, what we've done is to identify something specifically called hunger. Okay, but we don't actually see hunger. You look around the room right now. If we can get a wide shot of the studio for just a second, I want to ask a question of you. Look around the room, see if you can find anybody who's hungry. Okay? And now let me ask, how many of you would consider that right now you're hungry? By show of hands. Got a bunch of starving undergraduates here, I guess, except our happy rat who's sucking on a piece of candy. Okay? The point is that we never see hunger. And so what we have to do is to externalize it. We have to operationalize it in some way. That's going to lead us into the definition of three terms that I want to share with you. The first of these is independent variable. And we're going to define an independent variable as simply the factor that is selected by the experimenter and changed or altered, in other words, manipulated, to determine what its effects are. Okay? That is an independent variable. In other words, you and I select what things we're going to manipulate in a given experiment. Not only do we select or identify the variable, we also decide the values that are going to be associated with that particular variable. We could do a hunger experiment. I might be interested in trying to find out what is the most important or the best temperature for studying. And if so, what I might do is bring this class, the one that's in the studio here with me, into the room here and have the room temperature at 40 degrees. And ask everybody to read, say, 5 pages of psychological information and then give them a test. And then we'd go get another comparable group of students. We'd bring them in and have the room at 0 degrees. Let them read the same information and take the same test, and we would measure their response in that situation. In essence, the independent variable there, the thing that we're manipulating, is temperature. We're going to have one group at 0 degrees, another at 10, another at 20, another at 30, and we'll cover it all the way up to, say, 110 degrees. Maybe 120 if we can actually get somebody to tolerate that. But that's our independent variable. We're studying the effects of temperature on mastery of information, in other words, on learning. So our independent variable, we selected, and we actually defined the actual level at which it would be presented. Then we're going to look at a dependent variable. That's the second thing we need to worry about. And a dependent variable is essentially the factor that is selected, measured by the experimenter, the value of which may or may not change in accord with changes in the independent variable. Okay? So essentially, when we conduct an experiment, one of the questions we're asking is, does this independent variable impact this dependent variable? Are the two related to each other or not? So the dependent variable, we select and we measure, but it's the person or organism that we're studying that determines what value it will actually show up at. So if we were doing this experiment on the impact of temperature on learning, the actual amount of learning that would be demonstrated is determined by the performance of the people or organisms we're studying. So we select temperature to manipulate, and we select learning to measure. But it's the organism that actually determines what level, what amount of learning actually shows up. Okay? So we select and identify the levels of the independent variable. We identify the dependent variable, but it's the subject's performance. It's the person whom we're studying who actually determines where that variable will end up existing. Finally then, coming back to our hunger analogy a minute ago, the other thing we need to talk about is the intervening variable. In the intervening variable, that is defined essentially as a logical construct that is developed basically to account for events within an organism that occur between the independent and the dependent variable. In other words, what the you can think of the intervening variable essentially as a kind of scientific shorthand, if you want to think about that. What it does is to summarize all of the different ways in which we could impact hunger and all of the ways in which hunger would in turn impact the organism's behavior. Now, if you think about it, what we've actually done is to externalize the concept of hunger. because we never see hunger. We looked around the studio, you didn't immediately think, well, second one to the left looks really hungry, third one in from the right looks really hungry. You can't do that, at least easily. So in essence, we have to externalize it in some way. The way I did it was simply to ask people, are you hungry? And then a number of hands went up, which, now that's kind of goofy. Ask, are you hungry? And your hand goes in the air. Well, actually, that's because of the fact that we've socially agreed many years ago that we indicate agreement by raising our hand. But without, somebody from Mars might think that's like, gee, they're goofy. They're hungry, so they put their hand in the air. Separate issue. The point is that if you go back to the diagram in the simple Psych book, what you see there is hunger is an intervening variable, and we never see hunger. We see the things that lead up to it, and we see the things that follow from it, but we never actually see hunger. What we have to do is to externalize it in some way. We have to create it, put it in a realm where we can actually see what's going on. And so basically, when we study the interaction between independent and dependent variables, we're doing so by way of the intervening variable called hunger. So hunger basically summarizes the relationship that exists between variables like hours without food, how active you've been, the physiological efficiency of your stomach, and in turn we can measure that in a variety of different ways. We could assert, for instance, if you're hungry, you will eat. And relative to eating, we might measure, for instance, how much do you eat? We might indicate or measure, once we start measuring food, how rapidly do you eat? How long does it take you to consume the food? So there are a lot of different ways in which we could quantify the eating behavior that occurs. We could look at things like the amount of work that you'd be willing to do and assert basically that the hungrier you are, the more work you're willing to do. Of course, there's a limit to that. If we deprive you of food for a month, you're dead. So you won't work at all. So there's probably an inverted U relationship between hours without food and how much work you'll actually do. But in essence, the role of hunger in that situation is to summarize the nature of the relationship that exists between the factors that cause hunger and the resulting behaviors that occur because the organism is hungry. One of the other variables there that's mentioned is the physiological needs of the system. Okay? I'm sure you have friends like I do that have a massively efficient system, or I should say an inefficient digestive system. They can eat tons and tons of stuff they never put on a pound. They're always slender as a toothpick. I hate people like that. I, on the other hand, have a devastatingly efficient digestive system. If I eat anything, it's a lump somewhere on my body as a result of that. So one of the other variables that clearly impacts hunger is the efficiency of the digestive system that we have. Okay? And again, all of those relationships tie to the organizing concept, the intervening variable called hunger. And it simply summarizes all of the different relationships that exist between the various components of that diagram in the book. Now, once we get done conducting an experiment, we end up having to plot the data. And in this particular case, this is the way the data might end up looking. So if we were going to plot, for instance, the relationship between, or the summary of the impact of hours, not hours, I'm still hung up on the previous example, the impact of the temperature at which you study and how well you do on a test, where would temperature be on this graph? On the x-axis or the y-axis?
X.
X-axis, yes, because that is the independent variable. That's what we actually manipulated, okay? The y-axis would be your performance, or the group's average performance at each different temperature level, 0 degrees, 10, 20, 30, and so forth. Interestingly enough, with that kind of set of data, you get an inverted U. What do you think is the optimal temperature for studying? Any guess?
72.
70, 72 is what I'm hearing. It's lower than that, interestingly enough. The actual most efficient temperature for increased mastery of material is 68 degrees, exactly the temperature that the government recommends that we heat our houses to in the wintertime. Okay? So 68 degrees turns out to be the optimal temperature if, as a function of temperature, you're trying to maximize performance in terms of mastery of material. So the independent variable there was temperature. The dependent variable would have been scores on our test of material mastery. There are a number of other combinations that can also be used. Okay, I'm going to back up one from there so we don't confuse you. Let me see, I have to go page up to do that. Another pair of words that will identify the same thing is antecedent and consequent condition, antecedents and consequences. We manipulate the antecedents to see what the impact is on the consequences. The third possibility, I'm going the wrong direction, is predictor and criterion. Okay, we can use predictors to try and determine what the criterion will be. Fourth possibility, and you've already heard me use these words, is stimulus and response. The stimulus is what we manipulate. The response is what we end up studying in a given situation. And finally, cause and effect. Okay? So independent variable, antecedent, predictor, stimulus, and cause are all illustrations that, or concepts that end up typically being plotted on the x-axis, or as we sometimes call it, the abscissa. The effect, the response, the criteria, the consequences, the dependent variables are plotted on the y-axis, what we normally call the ordinate. So you can use abscissa and ordinate in a cocktail party this weekend and just blow people out of the water about how scientific you sound. In general, we use these words as pairs. We almost never talk about an independent variable and responses. If we talk about an independent variable, we talk about dependent variables. If we talk about causes, we talk about effects. We do not talk about predictors and consequences. We talk about predictors and criteria. So usually they are used in word pairs. And for all practical purposes at the introductory level, they're essentially comparable to each other. There are reasons why we use different terms under different conditions, but for the most part, you can be comfortable with the idea that these words are used in pairs. Now let's define the specific terms that we're interested in here. First of all, when we talk about a stimulus, there are 2 or 3 different ways in which you can define it, but in essence what it boils down to is any change that occurs in the physical energy or the environment. Any change in some aspect of the environment constitutes what we would call a stimulus. The other 2 definitions are essentially variable definitions of the same thing. They're various definitions of the same concept. So those are the stimulus conditions that we're working with. Those are the things we manipulate as our independent variables. In addition then, we also worry about responses. Those can be a little more easily defined for yourself in those forms. Essentially, it's the reaction that is elicited by a stimulus. Now what I'd like to do is to look at a variety of different response measures that we can actually utilize. We have several different ways in which we can, in fact, quantify people's behavior. One way is to measure essentially the latency of a response, how long it takes for a response to occur. Latency measure is essentially how long it takes from the time the light goes green till the guy behind you honks is a latency measure of behavior. That's one way to define it. In general, latency goes up the more tired we get, for instance. Second measure we can use is a duration measure. We can measure the length of time it takes. I'll give you another example of a latency measure, by the way. It's a cute demonstration. Take a dollar bill, hold it over a student's, have a student get anyone get their index and thumb an inch apart and tell them they can have the dollar bill if they can catch it after you drop it, if they don't start closing their hands until after you drop the dollar bill. And when you release it, it takes longer for the signal to register and for the brain to say snap. And when the fingers close, the dollar bill has already fallen through. So you can get rich on the sidewalks of New York or Houston if you want to try that. But that's a latency or reaction time measure. Second one that is used then is duration or length. That's what we measure with Carl Lewis on a 100-yard dash. Or a football player is considered to be very good if they can do the 40-yard fully equipped, run 40 yards in 4.2 seconds. That's a staggeringly good time in terms of a latency measure. Third way we can measure is to measure the amplitude of a response, the magnitude or the amount of a response that occurs. Later on in the semester during motivation and motion, we're going to look at lie detectors. And a lie detector basically is a magnitude measure. What we're looking at on a dial is the swing of a needle from some kind of defined neutral point. The idea being the further the needle swings, the greater the likelihood that you're lying in a given situation. There are some problems with that measure, as we'll talk about later, but that's essentially an amplitude or an amount measure. Fourth measure we can use is to measure errors. The idea would be basically that as you learn something, error rates should go down. Or the other way to measure it is to measure number of correct responses. Theoretically, that will increase as you learn. Voting is basically a correct response or a positive response accumulator. The person gets elected who gets the most positive responses. Another example of that is auto rallies. Not ones that are done on racing time, but rather on accuracy, where you're given a route. When the race starts, you're given a map and a route and an estimated time to do each leg, and then they've got observers at each of the checkpoints. And you are scored basically with deducts the further off the projected time you are. That is, they've taken the distance and the time limit or the speed limit, and they multiplied to figure what the ideal time should be. And then what you're doing is contesting not to break the speed limit, not to underdo it, but to hit it as close to exact as you can. And the penalty then is assessed if you make an error. If you're under, you're penalized. If you're over, you're penalized. So the goal is not to do it faster than the record. It's to do it exactly on the projected time. That's basically an error measure that is utilized. Fifth possibility is to measure the frequency of a response. That's essentially percent of correct response. And I jumped ahead in my notes when I was talking there. Voting is an example of a percent correct response. In essence, if you want to win an election, the correct response is everybody pulling the lever for you. Maybe a better example is a baseball player's batting average. When the Astros are playing, we hear then, Bagwell or somebody has a batting average of 325 or something like that. By the end of the season, you're accumulating about 6 or 7 months worth of behavior in that one number. So basically a frequency measure or percent correct response measure is typically a long-term measure of behavior. A variation on that is a rate measure, okay, where a ball player's batting average is typically a season-long average. A rate measure is essentially momentary. What we're looking at is responses per time unit. Miles per hour is an example of one of those measures. So if you get tagged doing 80 miles an hour in a school zone, it does you no good at all to say, but officer, my average speed since leaving the house is 19 miles an hour. That would make you legal in the school zone if you had been doing 19 miles an hour at the time, but you weren't. Your momentary rate is what's measured and what you get a ticket on. It's a rate measure that gives you a ticket, not a frequency measure, not a long-term measure that is involved. Now, why is all this measurement so important? Well, in essence, all these different, and there are a number of other ways that we can quantify data. I've just given you some of the most commonly used measures by psychologists. In essence, what we're ultimately looking for is to be able to establish laws. And we have a variety of different kinds of laws that we can actually establish. One of these is what's called an SR, or stimulus response law. The summary that I gave you earlier of the relationship between temperature and how much you learn in a given time or study effort is one example of an SR law. Okay? That's a stimulus response relationship. The stimulus in that case is temperature. The response is efficiency or learning ability. Okay, that would be an example of an SR, or stimulus response law. It's essentially a functional relationship between a particular stimulus situation and a given response. That's a stimulus response, or SR law. The other type of law that we can also talk about is what we'll call an RR law. An RR law is essentially a response law. It is a measure of one set of responses compared against a different set of responses. Several examples I could cite. When you applied to the university that you're in now, you had to supply a high school grade point ratio, a high school GPA or grade point average. Okay? That turns out to be a reasonably good predictor of your performance at the University of Houston. The better your school, the closer the correlation will tend to be. But it is usually positive. The better you do in high school, the better you're likely to do in college, because in essence those are two activities that share a high degree of similarity. There are arbitrary deadlines. There is exposure to information you haven't typically encountered before. There are arbitrary people laying rules on you that you have no control over, and so forth. And that describes both a high school environment and some aspects of a college environment. And so the net result is, as we talked way back at the beginning of the semester, college is not designed for everybody. It's designed, among other things, for people who do well in high school. And therefore, that's one of the things we look at when we admit you to the University of Houston. Interestingly enough, there's a subset of your high school GPA that actually correlates even more highly with your college grade point ratio than does the entire high school ratio. And that's one that our admissions office also calculates, and that is a sub-ratio, if you want to think of it that way, based entirely on the core science and math courses. If we look just at the core science and math courses that you took in high school, we can actually do even a better job of predicting your grade point at the University of Houston. Those are two variables that are positively related. As high school grade point average goes up, college grade point average tends to go up. There's another example I could give you. Obviously, things like the TASP test or the SAT are examples of measures that are correlated with college grade point ratio, but I'm thinking specifically of another one. Given the age of most of the viewers, it's one that most of you have gone through within the last 2 or 3 or 4 years of your life. What is it? It's a state-based test, which is essentially an RR relationship. What is it? It was important to you, too, to pass.
TAS?
Bingo. What was it?
Driver's test?
Driver's test, exactly. You remember that? You're 16, you get in a car with some guy named Stud. Remember the big burly arms and the tattoo? And he directs you around a 6 or 8 block course in the neighborhood, as long as you don't run over old ladies or dogs, as long as you don't run stop signs, and as long as you don't put your rear wheel too far up on the curb when you're parallel parking, you get a license. And in essence, if you don't ever leave the state of Texas, you will never be tested again. That is the ultimate RR relationship, if you think about it. I don't believe it. I think it's ridiculous to think that how you and I perform at age 16 when we're nervous bears any direct relationship to our skill as a driver when we're 55. I just don't think there's any relationship that exists at all. My mother, who died at age 78, was a terror on the road the last several years of her life. She lived in Maryland, and when I was in Maryland, if I knew she was going to be driving, I left my car in the garage. I wanted to be safe. Maryland, among other states, is beginning to wise up to the lack of relationship between performance at age 16 and what you do at 60 or 70 or 80. From age 70 onward, you have to take a vision test for 5 years. Between 70 and 75 in Maryland, at the time she was alive, you had to take a vision test. So every year she went down to the driver's bureau, got in line, and sidled up toward the front. When she got near the front, she got kind of confused with her purse, and she was fishing through like she was looking. Oh, here, go ahead, it's okay. And she'd let about 3 people ahead, and she listened. And she would hear people say FRQMLZ. Went through that about 3 times to make sure she had it right, and then she said, I'm okay. Step it up, FRQMLZ. Got her driver's license. No trouble, no trouble. At 75, Maryland now requires, or at least at the time she was alive, required a driving test every year. That got to be a lot harder. And finally, the 3rd year, she did not make it, much to the relief of many drivers in the state of Maryland. I mean, she never had accidents, but it was a little frightening to actually drive with her. But in essence, what that was reflecting is some implicit recognition by some states that there is a limit to the power of RR relationships. We will be studying those in the next section of the course, but I'm going to go ahead and start. Actually, there is another concept we need to talk about here today, and that is that when we start trying to establish laws, in essence what we're doing is experiments. When we try to establish laws, what we're really trying to do is to establish functional relationships between independent and dependent variables. And what that constitutes is the conducting of an experiment. And an experiment is essentially, as indicated here, simply an organized attempt to establish that relationship between independent and dependent variables. There's another way to define it, which is essentially different words to say the same thing. But that, in essence, is what an experiment involves. There is a disagreement in psychology right now about how to define who or whom we're studying. Some psychologists will refer to subjects. When a psychologist says subject, what they're referring to is an individual, animal, or human, in other words, the organism, that is in fact being studied in a particular psychological experiment. The other word that you'll sometimes see is participant. One or the other is going to be important. Now, in essence, the other key thing that separates science from other ways of doing research is essentially the use of what is called a control. A control is very important in establishing the impact of an independent variable. And in essence, what I'm going to argue here is that when we do an experiment, these are the basic steps that are involved. And I will come back and define each of these for you a little bit later in the course here, within the next lecture or two. But we create a sample, a population. We identify a population. We randomly select from them. We apply the procedure and do each of the steps there in one of two ways. If we do a between groups comparison, like the experiment we talked about earlier with the impact of temperature on learning ability, that's a between groups comparison, because when you're studying material at 40 degrees, we can't then have you learn the same material at 20 degrees, because you already know it. So we use between groups comparisons. The other possibility is use a within groups comparison, where you essentially study the same factor within the same individual. If we wanted to measure your weight loss, we would have a base rate to get control, then we'd have you weigh yourself for 2 weeks and just record it. The next 2 weeks we'd have you base rate and then have you write it down in a book, and finally we'd have you wear a board. If I'm on a diet, if you see me eating, ask why.